Hello and welcome, I'm Alexandria Acosta, and today I will be answering the following questions. What is nuclear fusion? How does nuclear fusion occur in nature? What is the equation for a nuclear reaction? How can we create it on Earth, and what can we use it for? What is nuclear fusion? In nuclear physics, nuclear fusion is a reaction in which two or more atomic nuclei come close enough to form one or more different atomic nuclei and subatomic particles, or they fuse together. The difference in mass between the products and the reactant, which is the substance that takes part in and undergoes change during reaction, is shown as the release of large amounts of energy. For fusion to take place, it requires a lot of pressure and heat. This extreme pressure and heat is needed because, as we know, like proton charges will repel. So this extreme pressure and heat is necessary to go beyond that repulsion. How does nuclear fusion occur in nature? Fusion is what powers the sun. Obviously, there is intense heat on the sun, but there is also an incredible amount of pressure at the sun's core. There are also huge amounts of hydrogen atoms in the sun's core that are compressed. At this compression, the heat and the hydrogen atoms will fuse together. What is the equation for this reaction? Please look at the screen below. How can we create it on Earth, and what can we use it for? We have managed to create nuclear fission, but not a sustainable process for fusion. Nuclear fission, splitting the nuclei, is a problem because resources are finite and rare. The waste products and the reactants are radioactive, and we must take some major precautions so that we do not contaminate the air, water, or the planet. Finally, environmental disaster. Chernobyl is an example of what can happen with human error, and Fukushima Daiichi, which, while it was primarily caused by a tsunami, it was nonetheless a catastrophic disaster. Nuclear fusion will allow us to create even more energy than we can with nuclear fission, about 3 to 10 times as much on average. Resources are very plentiful. There's almost no radioactivity, and environmental risks are non-existent. It's really the ultimate green energy and could potentially meet all of our energy requirements for millions of years. While we know how to make this happen, the problem we have is we haven't figured out how to reach what is called the break-even energy point in the fusion process. This is where we get out at least as much energy as we put in, and we need to figure out how to do this without causing the explosion like a hydrogen bomb. I hope this helps all of you at home have a better understanding of what nuclear fusion is. Now spread your newfound knowledge to your friends, coworkers, peers, and family. I'm Alexandria, signing off.